Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will find the vertex and the axis of symmetry for a quadratic function, given in general form f of x equals ax squared plus bx plus c. We will first state the theorem, then we will prove it by completing the square, and finally we will visualize minimum and maximum cases on a graph. Theorem: for f of x equals ax squared plus bx plus c. 1. The vertex is the point A with coordinates open parenthesis negative b over 2a, comma, for a c minus b squared over 4a, close parenthesis. 2. The axis of symmetry is the vertical line x equals negative b over 2a. Proof by completing the square. Step 1. Start with f of x equals ax squared plus bx plus c. Factor out from the quadratic and linear terms. Step 2. To complete the square inside the parentheses, add and subtract the term b squared over 4 squared. Step 3. The first three terms now form a perfect square. Rewrite them as open parenthesis. X plus b over 2a, close parenthesis squared. The remaining constant inside the brackets is, for a c minus b squared over 4 squared. Step 4. Distribute a to arrive at the vertex form. This yields f of x equals a times open parenthesis x plus b over 2 a close parenthesis squared plus open parenthesis for a c minus b squared close parenthesis over 4a. From the vertex form, the vertex is at x equals negative b over 2a and y equals 4 a c minus b squared over 4a. The axis of symmetry is the vertical line x equals negative b over 2a. Now, two cases. If it is greater than 0, the parabola opens upward, and the vertex gives the minimum value. Specifically, f of x is greater than or equal to for a c minus b squared over a c minus b squared over 4a. If it is less than 0, the parabola opens downward, and the vertex gives the maximum value. In this example, we will find the values of m and n for the parabola y equals x squared plus mx plus n, such that the axis of symmetry is the vertical line x equals negative 1. We will use a visual intuition with the vertex form and then match coefficients. Step 1. The vertex form of a parabola is y equals open parenthesis x minus h close parenthesis squared plus k, where h is the x-coordinate of the vertex and the axis of symmetry is x equals h. Since our axis is x equals negative 1, we set h equals negative 1. So the equation becomes y equals open parenthesis x plus 1 close parenthesis squared plus c, where c is any real number that shifts the curve up or down. Step 2. Now expand the quantity x plus 1 squared. We get y equals x squared plus 2x plus 1, and then plus c. So y equals x squared plus 2x plus 1 plus c. That is y equals x squared plus 2x plus open parenthesis 1 plus c close parenthesis. Step 3. Compare with the standard form y equals x squared plus mx plus n. Matching coefficients gives m equals 2 and n equals 1 plus c. This means m is fixed as 2 to make the axis x equals negative 1, and n can be any real number depending on c. Let us build intuition with a graph. We draw a coordinate system, and the vertical line x equals negative 1 as the axis. Now we will plot the family y equals the quantity x plus 1 squared plus c for a few values of c. Notice that all parabolas share the same vertical axis, but their vertical position changes with c. This is why m must be 2, because the axis for y equals x squared plus mx plus n is x equals negative m over 2, so setting that equal to negative 1 forces m to be 2. To conclude, the parabola y equals x squared plus mx plus n has axis x equals negative 1 if and only if m equals 2. The parameter n is free and simply moves the parabola up or down. So the complete description is m equals 2 and n is any real number. Quick check. If m equals 2 and n equals 3, then y equals x squared plus 2x plus 3 can be written as y equals the quantity x plus 1 squared plus 2. Its vertex is at negative 1, 2, and the axis is x equals negative 1. Example: we will solve this quadratic geometry problem step by step. The line y equals -5 over 2 intersects the axis of symmetry of the parabola y equals 1/2 x squared minus 3x plus a on the parabola itself. Find the value of a. Geometric insight. The only point common to a parabola and its axis of symmetry is the vertex. If the horizontal line, y equals -5 over 2, meets the axis of symmetry on the parabola, it must pass through the vertex. Therefore, the y-coordinate of the vertex is -5 over 2. To get the vertex, we complete the square. Start with y equals 1/2 x squared minus 3x plus a. Factor out 1/2. Y equals 1/2 times the quantity x squared minus 6x plus 2a. Now complete the square inside. X squared minus 6x equals the square of x minus 3 minus 9. So we get y equals 1/2 times the square of x minus 3 plus the fraction 2a minus 9 over 2. From this vertex form, the vertex is at x equals 3 and y equals the fraction 2a minus 9 over 2. Since the vertex lies on the line y equals -5 over 2, we set the vertex y equal to -5 over 2. Solve. The fraction 2a minus 9 over 2 equals -5 over 2. That gives 2a minus 9 equals -5. So 2a equals 4. Therefore it equals 2. Let us confirm visually. We will draw the parabola and the horizontal line y equals -5 over 2. Then we set a to 2 and watch the vertex land exactly on the line. Final answer, a equals 2. Welcome! In this lesson, we will find the value of m so that the point S of m, m minus 2 is the vertex of the parabola y equals x squared minus 2x. We'll solve this using two conditions. First, the point must lie on the parabola, and second, its x-coordinate must match the vertex x-coordinate. Let's build intuition with a graph. We draw coordinate axes and plot the parabola y equals x squared minus 2x. We will then locate its vertex visually and compute it algebraically. A fast way to find a vertex is to use the formula for a parabola y equals ax squared plus bx plus c x subvertex equals -b over 2a. Here, a equals 1 and b equals -2. So x subvertex equals -2 over 2 times 1, which is 1. Condition 1. If S of m, m minus 2 is on the parabola, then its coordinates satisfy the equation y equals x squared minus 2x. So we substitute x equals m and y equals m minus 2 to get m minus 2 equals m squared minus 2m. Now rearrange everything to one side. We get m squared minus 3m plus 2 equals 0. Factor the quadratic. It becomes open parenthesis, m minus 2 close parenthesis times open parenthesis, m minus 1 close parenthesis equals 0. Therefore, m equals 2 or m equals 1. But we still must enforce that S is the vertex, not just any point. The vertex x-coordinate is 1. Since the point S has x equal to m, we must have m equals 1. That selects the correct value. Let's visualize both candidates on the graph to build intuition. We place S of 1, -1, and S of 2, 0. Only S of 1, -1 sits at the vertex, so that is our final answer. Therefore, the value of m that makes S of m, m minus 2 the vertex of y equals x squared minus 2x is 1. In this lesson, we will solve for the parameter in the quadratic function y equals ax squared plus 2ax minus 3, given that its vertex lies on the line y equals x. Here is our problem statement. We have y equals ax squared plus 2ax minus 3. The vertex lies on the line y equals x, the bisector of the first and third quadrants. Let's draw a coordinate plane and the line y equals x so we can visualize the condition. We'll set up axes and sketch the line y equals x. Step 1. We will complete the square to convert the quadratic into vertex form. First factor out from the x terms. Then complete the square inside the parentheses. Distribute and simplify to get the clean vertex form. Step 2. Identify the vertex. In vertex form, y equals a times x plus 1 squared minus the quantity a plus 3. The vertex has coordinates h equals -1 and k equals -a minus 3. So the vertex is at -1, -a minus 3. Notice the x-coordinate of the vertex does not depend on a, it is always -1. That means the vertex always lies somewhere on the vertical line x equals -1. Step 3. Use the condition that the vertex lies on the line y equals x. The vertex coordinates are -1 and -3. On the line y equals x, the y-coordinate equals the x-coordinate, so y-coordinate equals the x-coordinate, so -3 equals -1. Solve for a. -a equals 2, so a equals -2. Let's verify by graphing the parabola when it equals -2. We will draw y equals -2x squared minus 4x minus 3 and mark its vertex. The vertex should be at -1, -1, which indeed lies on the line y equals x. We will solve a quadratic minimum problem step by step with an intuitive graph. Here is the function. We will find whether it has a minimum or maximum, the x value of the vertex, and the function value there. Step 1. Determine the direction of the parabola. In a function ax squared plus bx plus c, if it is greater than 0, the parabola opens up and the function has a minimum. For our function, a equals 9, b equals 6, and c equals 3. Since there is 9, which is greater than 0, f of x has a minimum value. Step 2. Compute the x-coordinate of the vertex using x equals -b over 2a. Substitute b equals 6 and it equals 9. That is -6 over 2 times 9, which is -6 over 18, which simplifies to -1 over 3. Step 3. Substitute x equals -1/3 into f of x to get the minimum value. Compute f of -1/3 equals 9 times -1/3 squared plus 6 times -1/3 plus 3. That is 9 times 1/9 minus 2 plus 3. That simplifies to 1 minus 2 plus 3. The result is 2. So the minimum value is y equals 2 at x equals -1/3. Let us visualize the parabola to cement the idea. We plot f of x equals 9x squared plus 6x plus 3 and mark the vertex at -1/3, 2. Notice the graph opens upward, and the vertex is the lowest point, confirming this is a minimum. Final result. The minimum value is y equals 2 at x equals -1/3. Great work! Example. In this problem, we will find the maximum value of the quadratic function f of x equals 4 plus 8x minus x squared, following the textbook algorithm step by step. First, let's put the problem on screen and set up a quick visual intuition. A quick intuition. This is a downward opening parabola because the coefficient of x squared is negative. Let's sketch the curve and its vertex to visualize the maximum. Step 1. Determine the type of optimum. For a quadratic ax squared plus bx plus c, if it is less than 0, the parabola opens downward and has a maximum at its vertex. Here, a equals -1, b equals 8, and c equals 4. Since it equals -1 is less than 0, f has a maximum value at its vertex. Step 2. Find the x-coordinate of the vertex. Use the vertex formula x equals -b over 2a. Substituting a equals -1 and b equals 8 gives x equals -8 over 2 times -1, which simplifies to x equals 4. Let's mark that on the graph. Step 3. Evaluate the function at x equals 4 to get the maximum value. We plug in x equals 4. F of 4 equals 4 plus 8 times 4 minus 4 squared. That simplifies to 4 plus 32 minus 16. So f of 4 equals 20, which is the maximum value. Final answer. The maximum value of the function is y equals 20, occurring at x equals 4. Let's show the final result clearly. In this lesson, we will find the minimum value of the function x plus 2 over x for x greater than 0 using the quadratic method. We will transform the function into a quadratic in x, use the discriminate condition, solve the resulting inequality for y, and then find the x value where this minimum occurs. Step 1. Convert the function to a quadratic in x by introducing a new variable y. Let y equal x plus 2 over x. Multiply both sides by x to eliminate the denominator. Bring all terms to one side to obtain standard quadratic form in x. Step 2. For x to be real, the quadratic must have real solutions. The discriminate delta equals b squared minus 4ac. Here, a equals 1 b equals negative y, and c equals 2. So delta equals y squared minus 8. For real roots, delta must be greater than or equal to 0. Step 3. Apply the condition delta greater than or equal to 0. From y squared minus 8 greater than or equal to 0, we get y squared at least 8. Therefore, the absolute value of y is at least 2 times the square root of 2. Since x is positive, y equals x plus 2 over x is also positive. Thus, we keep the positive branch. Y is at least 2 times the square root of 2. The minimum possible value of y is 2 times the square root of 2. Step 4. Substitute y equals 2 times the square root of 2 into the quadratic. We get x squared minus 2 root 2 times x plus 2 equals 0. This is a perfect square. Quantity x minus root 2 squared equals 0. Therefore, x equals root 2. The function attains its minimum value 2 times the square root of 2 at x equals root 2. To confirm visually, here is the graph of x plus 2 over x for positive x. Notice the curve decreases, reaches a lowest point, and then increases. The lowest point occurs precisely at x equals root 2, where the y value is 2 times the square root of 2. Final result. The minimum value of the function x plus 2 over x for x greater than 0 is 2 times the square root of 2, and it occurs at x equals root 2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.